This is the sixth in a series of quarterly reports that feature progress being made by NASA's ARES Projects Office. ARES finalized its industry partnerships for three major hardware elements this quarter. ATK Launch Systems, Pratt & Whitney Rocketdyne, and Boeing are on board with the ARES One Instrument Unit Award set for December. Engineers conducted tests to verify the aerodynamic environment during first stage re-entry. These data will help calibrate the altitude switch assembly, which triggers the parachute recovery system on the first stage. Another series investigated stage separation aerodynamics on the ARES One X-Flight test vehicle, set for an April 2009 mission. These tests allow project engineers to better understand the environment during separation, which occurs at a speed of Mach 4.5. The ARES Projects Office conducted its second major milestone review. The System Definition Review compared the elements' predicted performance against constellation requirements. A successful test drop was conducted on the first stage pilot parachute. The pilot chute pulls out a second parachute which stabilizes the booster as it descends. The test article was dropped from a C-130 and was in free fall for 10,000 feet to reach the correct speed and pressure levels. Another drop examined the 150-foot diameter main parachute needed to handle the mass of the 5-segment solid rocket booster. The 20-ton drop vehicle was released at more than 17,000 feet. Tests for the pilot, drogue, and 3 main parachutes will continue through 2010. Panels of aluminum lithium alloy are being machined as part of an upper stage manufacturing demonstration test. This allows AMRO to perfect their bump forming technique for bending the panels to the correct shape. After heat curing, they are checked to ensure that no defects exist and that they conform to the drawing specifications. Smaller panels were used to study compression loads. This series of tests established the panel's strength and stability characteristics. A compression load was applied until the panel buckled under the strain. The final failure load on the lightweight panel was nearly 250,000 pounds. ARES personnel tested welding tools on rings 1/8 of an inch thick, the thinnest such materials ever welded by NASA. This process will allow designers to create the lightest possible fuel tanks for the ARES One. It also will help designers determine the ideal settings for the new alloys being used on the upper stage. Marshall's robotic weld tool continued installation this quarter with the delivery of the production development system. This system will be used to test processes and troubleshoot any issues for the larger robotic welding system at Marshall. The robotic weld head for the full-scale friction stir weld tool was also delivered, and checkout of the full system is underway. NASA and Mississippi officials formally broke ground in August on the first new NASA propulsion test facility built in more than a decade. The A3 test stand will be a 300-foot tall open steel frame structure on a 19-acre site that also includes a control center and propellant barge docks. Construction has already begun, with many of the more than 400 structural support piles already driven. The facility should be complete in August of 2010. Subscale testing began on the diffuser for the forthcoming test stand, which will simulate conditions to test the J2X altitude and orbital restart capability. This subscale testing perfects techniques for use on the full-scale stand when testing began in December 2010. Workers also refurbished the A1 test stand at Stennis to support the J2X testing. This stand will be used for sea level and development testing. With remodeling complete, engineers prepared the J2X power pack for installation at test stand A1. This power pack allows engineers to explore the limits of the engine design. Personnel will also gain valuable operations experience for future full-scale testing. The J2X team tested a 52-element injector at Marshall, verifying that it will provide the required performance for the engine. Earlier tests examined 40 and 58-element injectors. The J2X engine materials are also being upgraded from the original J2 engine to meet the higher performance requirements of the ARES project. Samples of 2 superalloys are undergoing pressure and cryogenic testing at Marshall. Dozens of tests have been conducted over the past 6 months around the clock. ARES project personnel got the word out about America's new launch vehicles this quarter. ARES exhibits travel coast to coast, reaching tens of thousands of people. If you would like more information about ARES plans and progress, please visit us on the web at nasa.gov/ARES.